Hi, everybody out there. Thank you so much for joining us this afternoon. We really appreciate your time as always. My name is Yuri Grinshteyn. I'm a customer engineer here at Google. And today I'm fortunate to be joined by a couple of new faces. First, we'll start with my co-host, Michel.
Hi, everyone. So that's Michel. I'm also a Google Cloud customer engineer, and I'm really happy today to have Yuri and Prashant to talk about ML.
Awesome. Thank you so much. Thanks for being here. Really appreciate your help. And then I'm also lucky enough to be joined by Prashant. Prashant, tell us what you do at Google.
Hello, my name is Prashant Dhingra. I'm a machine learning lead at Google. I work with customer and I build machine learning project for customers.
Awesome, thank you. So that sounds like really valuable experience, and I think that may help you shed some light on our topic today. So we got all dressed up because today we're talking about management, specifically the management of machine learning projects.
Yeah.
So tell us a bit about your experience in managing or leading these kinds of projects.
Yeah, I have 25 years of experience, and last 10 years I've been working on machine learning projects. Machine learning is different than software engineering. Its life cycle is different.
Mm-hmm.
So it requires knowledge of project management. It requires knowledge of machine learning life cycle. It requires knowing about how the data works. So by combining this thing together, one can effectively lead machine learning projects. And today we'll cover those tips and techniques, how you can plan for a machine learning project, how you can evaluate it, and how you can determine the work items for machine learning projects.
Awesome. I think that's going to be really interesting. Yeah. So if you're out there, if you're an engineer who is looking to implement a machine learning project and you don't quite know how to take it from inception to production,
yeah.
Or if you're a manager, a project manager, or a program manager, or a product manager, and you're trying to figure out like what is it going to take for me to take this idea that I have that might be better done with machine learning, and you want to know how to again take it from kind of an idea to production, and Prashant's going to teach us all about how to do that.
Yeah,
did I get that right?
Yeah, you got it right. And we, in the beginning of 10 minutes, we will also cover how to define strategy for machine learning.
Awesome.
And then we'll go into planning, and then we'll go into the execution phase.
Very cool.
Oh, that's very good.
All right. So with that, please, let's get started.
Okay. Thanks a lot. So when an enterprise wants to start a machine learning journey or AI journey, they generally have a pain point and they have an idea how to solve that pain point. So for today's discussion, let's take a case study or an example case that there is a city council. The population in the city is growing, and the city council has an objective that they want to keep the city clean with a growing population, and they also want to reduce the cost of cleaning. They have an idea that if they can take the images from the street and determine where there's a garbage, they can send a cleaner there and clean the city and clean that specific space. And they think the machine learning can solve that problem.
So this is a problem that's near and dear to my heart. I lived in San Francisco for a few months. And while I was living there, we had scheduled street cleaning. There was this big truck coming down the street every other week or every week. And everyone had to go move their cars, find another parking space that night, which if you live in any big city, that street parking is a problem to begin with. So yeah, if they could have done a better job of actually figuring out when to send that truck based on whether the street needed to be cleaned, rather than just sending it all the time, that would have made my life a lot better.
Yeah, absolutely. So once a company has an idea, then they determine that, okay, what kind of a model they need to build. So for example, in this case, they need to build a model which can take images as an input, and then it can classify where there's a garbage in that image or not. If that model works, then they know that they can put it into production and operationalize it. So they start with an idea, then they work on building the model. Then the next step is, if the model is working, how to put it into a production. At this stage, the focus shifts from machine learning to the engineering. Once they put into the production, then comes the change management phase, where all the business process needs to change. For example, in this scenario, instead of doing a schedule-based cleaning, it will be an event-based cleaning. Whenever there is a garbage, they will send a truck or they will send a cleaner to clean it. And that requires a lot of change management, a lot of KPI changes, etc.
It's transformational, certainly.
Yes.
It's going to change the entire company.
Yes. And at that point in time, when you're able to change the business process, you will be able to generate the ROI. And that is the fruit of doing the machine learning project. And if you are successful in doing one machine learning project and doing an ROI, then you will have other departments in the company. They will have similar ideas. They will say, okay, can I also take images from the street and identify where the lights are broken, or whether there is a like broken beer bottles or similar use cases. At that point in time, every department need not have to build the same pipeline. That time, companies start thinking in terms of a machine learning platform. What common functionality they need to build, which each department can use. And then they invest in the machine learning platform. Some companies even take it further. They have a platform and they productize it. For example, Google has a TensorFlow platform for our internal usage. Then we outsource, then we open source it. And after that, we also put it on a cloud as a managed service. So some companies also productize the platform. And then few companies take it even further. They build a SaaS application. The advantage of SaaS application is when you're giving a platform to your customer, the customers needs to build application using platform. Yeah. But in a SaaS application, you are giving an end-to-end application, you're giving an end-to-end data collection and machine learning built in, and customers are simply using it. So when you are defining a strategy for your organization, think about what is your final destination, because that will help you in planning what kind of things you should think upfront. One other aspect you should consider is if you are an enterprise and if your final destination is a platform or just one use case, your core focus is finding out whether you will get value or ROI from this use case and by implementing the machine learning. But if you want to go in the productization or building a SaaS application, then you also need to ensure that not only you are generating value for yourself and your customer, you are generating unique IP also. The unique IP can be in the form of a data or in the form of a machine learning technique. Because if you do not have a unique IP, you only have a value, then it becomes easy to copy. And then, so plan for your strategy by considering this journey and determine your destination.
It's interesting that you actually listed Google as an example, because we have very much kind of gone through every phase of that journey, right?
Yes.
Like you said, right? We had TensorFlow. That was something we were using internally. We then published it as technology. But then also, if you look at like what we're exposing to customers, right? You can use TensorFlow as a service from us and Cloud ML Engine. Yes. You can also consume machine learning via APIs, so you don't really need to use TensorFlow.
Yeah.
So we're sort of giving you a platform. So we've productized it. But then we've then taken machine learning and built it into our software solutions. Like G Suite has all kinds of machine learning in it, right? There's that explore button that kind of just gives you these magical insights.
Yeah.
So like if you want to think of a company that's sort of done all of this, yeah, Google is like an easy example to think of.
Yes, Google has gone through all this journey, and like we are sharing the learnings we have with the customer so that they can plan their journey better.
Mm-hmm. Very good. Okay. All right. So now what?
So let's focus on this use case. Now, City Council has an idea that they have a pain point, that there is a garbage on the street. They know that if they can find out using machine learning where there is a garbage, they can send a cleaner and get the city clean. So that's their solution. And the outcome will be there will be a cleaner roads.
Yeah. And the street I lived on looked very much like the one on the left there, much more so than the one on the right.
And they have a high-level solution that they can use IoT, big data, and machine learning to build this end-to-end scenario. So using IoT, they can collect images. They can put the images into a big data solution, and then they can apply machine learning to classify where there is a garbage. And Google Cloud provide all of these platforms. We have a Google Cloud IoT, we have a big data solution, and we have a machine learning solution, and they integrate very well.
Okay. Awesome.
That's very good.
So all right. Using this, you define your high-level AI strategy, then focus on your business use case. So business use case, you need to answer multiple things in a business use case. Who is your customer? Who is your user? Many times they are same, many times they are different. Example, in this case, City Council is your customer, but user is the citizens of the city. So you need to take into account what they want from the solution. Define the business problem in detail. Then specifically define why you want to use machine learning, because many solutions can be better done by rule-based system. In this case, a rule-based system can identify garbage from other images. So machine learning is the right solution. So it puts a business case, yes, use machine learning. Then also define, are you improving existing use case, or you are defining a new use case altogether? Then determine whether you are building a new model or you need to turbo boost existing model. So example is, till 2 years back, there were translation model, but they were not good enough. So at that point in time, we were investing in turbo boosting the model. But in this scenario, today's scenario, we will focus on the new model building. Then determine what are the data sources you have, whether you have rights to get that kind of a data, whether it is ethical, legal, and compliance to get those data. And also focus on your ROI, whether your ROI is to generate new revenue or your ROI is to save cost or improve safety, improve cleanliness, etc. What is the success criteria?
Your point about data there is actually really important. every customer that I have talked to that is trying to address a machine learning problem, the first thing they run into is the data. They have to go and understand, what is the data that's available to us, what data exists within the organization as a whole and kind of broadly. And like you said, right, what data do we have the rights or access to, right? So it's like, does the data exist? Does it exist where we can get at it? Can we get at it? Are there compliance issues or restriction issues? And then there's, things like data quality come into effect, right?
Yeah, absolutely.
Yeah, data preparation, making sure that you will be able to use that in your ML. And we have tools to help anyone just to do preparation of the data.
Preparation of before they invest into machine learning or before they hire resources to do machine learning, they need to ensure that they have the right data.
Yeah, absolutely.
And then if we are focusing on generating revenue, then determine their pricing model, who will buy, at what price they will buy, and how they will maintain the solution. So think about these questions. You might have few more questions, but I think these generally covers the business use case. So if you answer this question, you will be able to put together a good business use case for machine learning.
Okay. So what you're describing here is definitely the 10 steps you have to go through before you start any ML project.
ML project, yeah.
Okay, and it's going to guide you for the next steps. That's really good.
Okay, so now you have defined a business use case, you had a high-level strategy. Now let's discuss like how you can plan for this machine learning project. So for today's example, our use case is we want to identify which image has a garbage. So we'll define how to put together a plan for a machine learning project. So first, quickly, if you know project management, continue using the best practices from the project management, determine why, what, and how. Like what are the driving factors for running this use case? What are the benefits you are going to expect? What business changes, process changes you need to do? What capabilities you want to build? And how you will get the outcome and which technology will enable it. So continue using that. We'll not spend time on this today, but here's an example from a PMI book, like how to prepare a portfolio, like portfolio, program, and project, and how to tie them together.
So that might look scary, but you should probably reassure our viewers that it's actually not nearly as bad as it looks.
Yes. So your project might be part of a bigger program, and your program might be part of a bigger portfolio. So knowing about what portfolio it is part of, you can be aware, like if your organization policy changes, so your project will get impacted. So just follow the best practices from the PMI book. Then the next step is identify your stakeholders. So we saw this diagram earlier. Determine in what phase of a machine learning project you are in. So when you are building a model, at that point in time, you have only few stakeholders. For example, few executives or sponsors will be interested, few business users will be interested, and some data scientists will be interested. But if you start demonstrating that you are getting good result, suddenly a lot of business users will be interested.
Yeah.
So pay attention to your phase and which stakeholders are interested, and also be aware which stakeholder will be interested if you get good result. So when you build a model, few stakeholders. When you operationalize a model, more engineering teams will be interested. When you put that model as part of a business process, like a lot of team doing change management, lot of team doing a business process will be interested in that. So have a list of these stakeholders so that as you get result, you can share the finding with them, and then they will start participating.
That's a definitely good point, and this is one of the questions I had to you. So what are definitely the key milestone you definitely have to make it right in the project lifecycle, so that you're sure that you are going to end creating success faster?
Yes. Yes. So once you define a use case, your whole use case might be a machine learning use case, or a subset might be a machine learning use case. So in this case, our machine learning model is one component. So that is your milestone, what kind of accuracy you will get when you look into images. Okay. If you are able to get the right accuracy, which will generate the good ROI, then the next milestone will be integrating that as part of a end-to-end pipeline. And once you are able to integrate it, then the next milestone is changing your business process. Instead of sending the cleaner every day or every week, send it where it is needed. Okay. So those kind of a milestone you define. Similarly, in a platform building phase, there will be more engineering teams involved. And when you productize it, if you want to productize it, there will be more product managers involved, etc. So find out which stakeholders are relevant for current phase, and find out which stakeholders will be interested in the future phases, and put together inventory of your stakeholder interest and their tolerance. That will help you in managing the project well. So once you have a use case, then before you want to proceed, all business user, all executives wants to know the success criteria. So generally from a machine learning project, people wants to either reduce a risk, they wants to save money from the cost, or they wants to grow the revenue. These are the high level bullet points you will have in the success criteria. So check with your business users. Are they trying to reduce the risk, or they are saving cost, or they are trying to grow more revenue? And that will give you a pointer, okay, what additional question to ask from them. So if we take today's example, the city wants to keep the city clean, and they also want to save the cost. So their primary motivation is to save the cost. Then go deeper, like, okay, how much of images they want to automatically categorize as a garbage or not garbage. So customer will always say they want to get 100% accuracy. They want to get all 100% images to be classified correctly. So at that point in time, discuss with your customer, what is a reasonable success criteria? For example, I'm just taking an example here. If you have a benchmark that a simple model can be built on images, and that can give you a 90% accuracy result, then you can have a discussion with business that is the kind of result to expect, and not the 100%.
90% sounds pretty good to me.
Yes.
Yeah, compared to previous one.
Then dig deeper. Look into their data, because even if you bring the right skill and if you spend enough time, you can't do a magic. The type of result you will get is dependent upon the quality of data. So here is an example. If the images are blurry, and even if a human can't identify whether there's a garbage or not, the machine learning model will not be able to identify. So if the 10% of the images were blurry, then you will have a discussion again with business and say, we have an issue in the images. Either we need to get the right images, or we need to reduce our success criteria.
Is that real life experience?
Yes.
Okay.
Yes. So it happens in every case. This is the primary difference between software engineering and machine learning. In software engineering, we define the success criteria upfront because it is a rule. We write rules, and we know what rules programmers can write. But in this case, no matter how good a model we write, it depends upon the data. So look into the data and see what kind of a result it is going to give.
So kind of going back to that thesis that a machine learning problem is a data problem first.
Yes, machine learning problem is a data problem first. Then you again look into data, and you realize that your labels on the images, which images are garbage or which images are not garbage, are also wrong. So if the labels are wrong, if labels are 1 or 2% wrong, probably machine learning nowadays new techniques can handle it. But if your labels are significantly wrong, it will also improve your result. It will impact your result.
Yes.
So again, have a discussion with business that labels are wrong. Either we need to first invest into label improvement and then build a model, or we can build a model first, and once business see a reasonable result, then they can invest in improving the label quality.
Yeah. So you've actually just kind of captured two levels of success criteria, right? The first one was really more about the business side of things, right? What is it that we're trying to do with this, right? Why are we doing the project? So what is it that we're going to be what is it that we're going to be considered for success in the project itself, right? Yeah. So that's either basically bottom line cost savings or top line revenue opportunities. And then coming out of that, that's when you start developing your technical success criteria. Yeah. Like how many images can we successfully classify? What is going to be our accuracy rate? How accurate is our prediction going to be, right? Whatever the thing that the model is actually doing. Yeah. And it is important to sort of understand both of that. Like, what is it that you're trying to do? And then how good does your model need to be in order to actually achieve that objective?
Yes, absolutely.
In that order.
Mm-hmm. Yes.
So understanding business first and second.
Yes. And then once you share this insight, generally customers are very happy because they appreciate this insight. Yeah. They know like how many images are blurry, and it helps them in making the right decision. Mm-hmm. So now we have a success criteria. We already have a business use case. The next thing we should do is we should convert a business use case into a technical machine learning use case. So generally in a use case, we have a business problem, we have a flow of event, flow of alternative events. You should have all these. But then for a machine learning use case, describe what impact machine learning will bring, how it will improve the existing scenario. Describe what you are trying to predict. So in this case, we are trying to predict whether image has a garbage or not. Describe the signals and data sources. So not only keep it at a scenario level, but describe which actual data source you will be using, how many labels it has, how many rows of data it has, etc. And then specify how you will measure the result. And now we'll go further. Now you should convert into a use case into a matrix. Because what data scientists will be doing is they will be building a model to optimize a matrix. So your use case is good for your business users so that they know like we are going after this scenario, and then you translate into a machine learning use case. But then this is a matrix you should give it to a data scientist, because they need to find pattern in data and then optimize for a matrix. So if you are a program manager on a machine learning, program manager deliverable is the matrix, converting a use case into a matrix. So it sounds simpler, but in many cases, defining matrix become complex. So in this case, we'll keep it simple. That if you want to classify garbage or no garbage, there are number of simple options. You can focus on what percentage of correctly classified garbage instances. If you do it well, you can ensure that the cleanliness is taken care. But if you focus on percentage of misclassified garbage instance, so if you have various images you are classifying as garbage and you're sending a cleaner, but there's no garbage there, it's impacting the cost. So check with your business which area is more important. They will generally say all these pieces are more important, which is fair, but at the same time, choose one primary matrix and remaining secondary matrix, and give your data scientists a ask that they need to optimize for the primary matrix, and they need to keep the minimal of satisfactory criteria for the secondary matrices.
Is it a sort of dashboard? No, just because I understand, at least for your use case, you're going to build this project for a certain period of time, and this is going to be productized, and there will be summer, there will be winter, there will be plenty of events that will change, might be the data quality or plenty of things. So using this matrix, you're able to see if it's still successful and return over investment is still valid.
Yes, absolutely. That's a very good point, because when we do a training, the matrices are very simple, like TP rate, TN rate. But when you actually use it in production, so you need to take care of, you need to customize those matrices. Like, is it okay to have snow or mud during the rainy season? Mm-hmm. Then you will basically not penalize if you are ignoring mud as a garbage.
Yeah.
So then your matrix will become more and more complex, and that's the reason it's a program manager job to convert a use case into a matrix which data scientists will be optimized for.
And this is again why it's important to understand that business use case, right?
Yes.
Because depending on whether you're trying to save money, or to increase revenue, let's say, that will actually help you determine whether maximizing the rate of true positives or true negatives is the right thing to focus on, or if you're actually trying to avoid false negatives or false positives, right? So in our city cleaning example, if the thing that we're really trying to do is save money, which basically means we want to send the trucks out as little as possible, then any false positives are directly hitting that, against that target, right? So in our example, we might actually be looking, like, the one thing we're going to be really focusing on is minimizing false positives, because the worst thing for our objective is to send a truck out when there's nothing to clean.
Yes. However, if a minister is visiting the city and on that day you want to keep the city clean, you will optimize for other metrics.
Yeah, exactly.
Yeah. And we took a very simple example where we only have two classes, garbage and not garbage. When you have a multi-class classification, matrix becomes more complex. And if you have a class balance, then you need to consider micro and macro matrix. And if you now take another example where you have a sequence of data, let's say in route prediction, etc., where you have one sequence, you are producing another sequence, the matrix becomes very complex. Yeah. Mm-hmm. So as a owner of a project, it's very important. It's a very important milestone to agree on a matrix which all the stakeholder and all the data scientists agree. Yeah. when you build a matrix, also ensure that the matrices are independent from the model design. Many times we do a model design first and then choose a matrix, which should not be done. For example, if you are building a DNN classification model or a RNN model, that decision you can take it later, but you need to select the matrix first. Similarly, the matrix needs to be consistent. So if there are multiple models that produce the same score, they should produce similar output.
Yeah. Yeah.
And matrix needs to be reliable also, so that you can produce it again on a different data set. And they should be easy to do, specifically if you are doing a prototype in 6 to 8 weeks time.
Yeah.
You don't want to spend 4 weeks only in writing a matrix code. So we talked about this, that if there are multiple matrices, then select one matrix data scientist needs to optimize for, and other matrix put a satisfactory criteria that, okay, these numbers should be above 80% or 85%. Okay, so now you have a use case. You have converted the use case into a matrix. You also have a stakeholder. Select a method to implement a project. So because model development is very agile, it requires a lot of iteration. So Agile method is more suitable than the waterfall method. So this is Agile Manifesto. Most of us already knows it. Like, we focus more on working software over documentation. We focus more on customer collaboration over contract negotiation. We respond to change quickly. So we use Agile method for building the model.
Do you have any experience on waterfall project used for ML, or would you recommend definitely using waterfall for certain environments? I'm asking.
So I will give you tell you a small story.
Okay.
There were 2 villages. One village has an elephant, and another village has a monkey. They both want to eat food. So first village sent elephant to get the food. Elephant goes into one direction or 2 direction. If it finds food, it bring it. If it doesn't find the food, it comes empty, because it can't go into 20 different directions. On the other hand, monkey can go in 20 different directions. It always finds food, but it is not big enough to fetch food for all of it. So then they met, the 2 villages met. They decided that in the morning they will send the monkey to figure it out in which direction the food is. The monkey comes back, sits on elephant back, then they go together and bring food for both.
No, that's a good one.
So
we need to adapt.
Yes, we need to adapt. Wherever there is a research needed, we should use monkey approach.
Yeah.
Wherever we know that, okay, this direction is going to give us a food, we should use a waterfall heavyweight approach.
That's brilliant. Yes. I really like that explanation.
So within Google, we have defined these cycles. This is a cycle for a machine learning. We go through 10 steps, like we define a use case, we explore the data, we see a pattern, we select an algorithm, we do feature engineering, we build the model, then we iterate to improve the model performance, we present the result with business, then we plan for deploying, and then we finally deploy and operationalize, and then we integrate the model with business process. So we use Agile method and little bit of waterfall method sometimes, specifically if you are sure in a plan for deployment and deploying and operationalization, you can use more heavyweight approach if you are clear what you are doing. And in generally between like 3 to 6, we generally use more Agile method.
Mm-hmm. Makes sense.
And this is another representation of the same 10 phases. So the first and second phase are generally use case and data heavy, and then the focus shift from the model building, and here the focus shift on the engineering, which can be more of an elephant approach. And finally, we do a lot of change management and we change the process, and then we continue to iterate on the process. This is the process we use, ML lifecycle we use within Google.
Okay, just one question on the process. In your experience, do you have any tool or any, let's stay on tool, because we've been talking about process, that will definitely help the development team to be able to collaborate so that iterations are going to be faster?
Yes, so one of the best practice we use is, we use one tool which has the work item, which has the use case, which has the matrix. So depending upon which project management tool you use, you can use a spreadsheet, and you can put a use case, you can put a matrix, and you can put a success criteria. Then you can start defining your work items, and you can start putting the result. The key is, if the whole team is using one tool, then the collaboration increases.
So it's collaboration.
Yes.
Yeah. Okay. Very good.
Okay, so now you have everything to plan for a project. Like you have a use case, you have a matrix, you can simply go and start a project. One of the challenge in machine learning project is you can have 20 different approaches. You can try all of these and then realize which approach will work. And each approach will take you a few months, but then you will be wasting a lot of time. So when you are leading a machine learning project, you need to use your experience to determine which approaches are likely to give you a result. And that's the role of a leader of a machine learning project. So you need to make various decisions upfront before you start putting together a detailed project plan, because the detailed project plan will vary depending upon which direction you want to choose. For example, if you take this use case for identifying whether there is a garbage on the street or not, you can go to a third party and buy the images that has garbage. You can download the images from web, but the images from web will be generic, and then you need to have a work item to label those images. If you buy from third party, you are directly buying good quality images. You can do another approach. You can launch an app, give it to citizens, that if they take an image and upload it, if there's a garbage near their home, immediately a truck will be sent and the cleaning will be done. So they will have a motivation to upload the images, and within 2-3 months of time, you will have a lot of good quality images, and then you can start building a model. So you can go in any of these directions. So you need to make decision which direction you are going. And then you also need to determine how much images you need. Sometimes you will, let's say city council says you like they have 100K images. You might say, oh, we need more images to do deep neural network. Sometimes they might say they have like 20 million images. So then you might say, okay, I need to use sampling techniques because training on 20 million is unnecessary. Sometimes you will say, okay, I need a data, but of a different data. For example, if you have data from a web, but that is not matching with what you were expecting. So you have a data, but you need a different data. So as a machine learning leader, you need to make those decisions. Do you need more data? Do you need to subsample it and use less data? Do you need a different data? Do you have enough labels, or do you need to fix quality of label? Or is there a class imbalance issue? For example, you might have enough images of street, but you might not have enough images of garbage. Or you might have images of garbage of a certain type, but not other type. So you need to go through, quickly go through the data and see like which direction you need to go. So in this case, let's take an example that we got images from city council, 200K images, and we also got images from 1 million images, generic images from web, and using that we will proceed. But depending upon a use case, depending upon what quality or what kind of a result you want, the leader of the project needs to ensure that these decisions have been thought through.
Okay.
So we talked about, so these are the example. We can take images from web, and then we can mix it with the 200 city council images, and then we'll talk it later. You can randomly shuffle it. That is one approach, or you can do more advanced approach that you mix 100K images with your training data, but then when you are evaluating the result, you are evaluating on the good quality city council images.
So you're making some cluster of image and which are going to be auto-labeled or something like that?
Because your goal is to optimize for garbage or no garbage. So for your train and test, you might want to keep those good quality images. And for training, you can train on generic images plus some good quality images. So there are pros and cons of this. So we'll talk about those pros and cons in the next few slides. So once you have made a data decision, you also need to think at high level what kind of a model you're going to build. For example, one model can be one-to-one, which is like you have an image and you have a class at the end, garbage or no garbage. Or it can be an image and you can have a multiple class, garbage, snow, mud, glass, something else. But architectures are very different. Your work items will vary a lot. You can have another architecture where you have a sequence of image and then you have a label called garbage or no garbage. So work with your customer and with the data scientist, like which model architecture you're going to build. The other two are generally used in sequence prediction. Like this example is used when you are translating. You have a sequence in one type and you're producing a sequence of other type, or in a speech, you have a sequence, you're producing another sequence.
You're showing the last two blocks many to many.
Okay. Yes, many to many. So make a right decision that you are going to build one-to-one or one-to-many, because it will have a very different work item.
And is it going to have an impact on time to be able to create the models, and on cost? Certainly no.
Yes. So if you are doing one-to-many, it will you need to have more work item, so your time will increase, your complexity of the model will increase. If you are using sequence as an input, so generally handling sequence is more complex than handling an individual item. Then you need to build a model which can handle time series or sequence of steps. So your model will become much more complex. And then also think what kind of algorithm you are going to pick. At high level, whether you are going to use supervised learning, unsupervised learning, semi-supervised learning. In this case, we'll use supervised learning and we'll use a classification model. In different scenario, you might be using regression model. So make decision before you start executing the project, what kind of a approach, high-level approach you're going to make. Once you have made that decision, also think of what kind of a ML platform you will use. So for example, in Google Cloud, we have a ML APIs, as you mentioned earlier. Developers can use it without writing any ML code. They can simply use it as an API. And because these are the pre-trained model. On the other side, then there is a AutoML, which let you train on your data. API doesn't allow you to train on your data. AutoML allows you to train on your data, but it gives you a limited customization. On the other hand, TensorFlow and Cloud ML engine gives you a lot of customization. You can do anything you want. You can build a very custom model architecture. So think through it, which kind of a platform you're going to use. Are you going to use API and just rely on the API output, or AutoML? If you want to do a quick POC, you can do a quick POC and test and determine which one will meet your need. So for today's example, we'll focus on TensorFlow and Cloud ML engine. But if API work, that is the easiest solution. If AutoML work, then that should be your next preference. If none of these work, then you should be building a custom model. Now you have decided to build a custom model, then determine what kind of a model architecture you will use. One can go into a lot of detail, will not go into a lot of detail today, but at high level, you can build a DNN classification, or you can build a RNN model, or you can build a CNN model. Generally, convolutional neural network is a better model for images. So one will use convolutional neural network, and there are a variety of convolutional neural network you can consider. Okay. So make that decision, have an agreement with data scientist and your engineering team, and then proceed with the detailed work item. Then also be aware of few techniques which might help you in saving cost and time. Like transfer learning is useful. So when you are training on images, transfer learning is useful, that you can use like pre-trained work. You need generally in a convolutional neural network, there are a lot of layers. So you can use pre-trained few layers, and then on top of that, you can train on your data. So that is the advantage of transfer learning, and using it will you will be able to save on the training cost, and you will be able to save on the time, and your need for data also will reduce. So you can take like few million images from web, and you can build end-to-end CNN model, or you can use transfer learning, and that will require easier model. Similarly, some teams use active learning. Active learning is useful to get more label data. So you may not want to do it in the beginning, but at a later stage, you can evaluate whether you will be benefit from it or not. So for example, when you have a model working in a production, model will say, okay, I can predict very accurately these many examples. These are 2000 examples where the confidence score is low. So instead of getting labels for those 2000 examples, active learning can help you which 50 items you should get human labels. If you get 50 items human label, you will be able to classify the remaining 2000 items. Yeah. So it will also help you in saving a lot of labeling cost. Then other technique is multitask learning. Generally in a classifier model, your output is one class. And that's what we called it out in one-to-one example. But if you want to get a vector as an output, for example, if there is an image, and if you want to see here there is a bottle can, here there is a mud, and here there is a snow, here there is some polythene bag lying, and if you want to classify each object individually, that's where the multitask learning is used. The reason you want to use multitask learning is you have two options. Either you use one-to-one model for each object type, then you will be spending a lot of engineering resources. Instead of that, you keep your lower layers common, and then you change your top layer. So instead of returning it as a one object, it will return a vector of objects.
Okay.
That's where the multitask learning is useful. And it has been becoming very popular nowadays, specifically when we take images from a street. On a street, you have a car, you have a pedestrian, you have a traffic light, you want to find all those objects. So multitask learning is effective in that area. So now we talked about use case, we talked about success criteria, we talked about metrics, and we talked about agile project management plan, and we talked about various technical decisions you need to consider, what kind of a data you will get, what kind of a model you will build, what techniques you will apply. Then you can build a plan for your 6 to 8 week of model building project. So generally in a project plan, we are used to seeing start date and end date. Because we are using agile method, instead of giving a start and end date, we are putting a range here. So in a 6 to 8 week project, we do not say like, okay, this item will start today and finish in 3 days time. We give it a range because many of these items are really agile. We do not know whether it will take 2 hours or 2 days. And most of these items, we can do it with a high confidence that we can do use case, we can finalize hypotheses, we can finalize metrics, we can upload the data, we can change the data, we can do data exploration. And then we generally do a checkpoint to see whether the data has a pattern, whether we'll be able to build a model or not. Then we start working on a model building, which includes algorithm selection, feature engineering, and building a model. I called it out a red. So I use a statement from a paper from MIT that model building is a dynamic and self-correcting process. It's difficult to plan in advance what kind of accuracy it will get and what kind of a result we will get, because it really depends upon the patterns on the data. So we educate our customers upfront that we are building this model by looking at the patterns in data, by looking at the use case. We have some confidence that the model can be built, but it actually depends upon the data.
Yes.
So that's the reason we call this model building thing in red. And once the model start giving us a result, then we prepare detailed design, which describe what all approaches we consider, what all approaches worked, which approaches didn't work, and we give it to customer. And then we also prepare a operationalization guide, what step or what kind of a pipeline one needs to build to automate the end-to-end process. And then we also prepare a detailed work breakdown structure for operationalization. So at this stage, we can use more of an elephant approach for the future work item that, okay, now the model is working and here are the work items for future and how to operationalize it.
I understand that definitely this portion is going to be depending on these metrics that you already created at the beginning.
Yes.
So if your model is successful, you're going to reach this the right metrics faster, and you're going to reduce or get something.
Yes, absolutely. That's a very good question, and that we should cover more in execution. So let me show you an example. So now you have a project plan. You go into execution. In execution, there are a number of things can happen. So let's take few simple examples. We'll not go into detail. Let's say you have built a CNN model. Your data scientist has built a CNN model, and data scientists share the result that on a training data, we are getting 75% accuracy, and on a validation data, we are getting 73% of accuracy. So generally, when we have a model building, we divide into train validation set. There can be another scenario where data scientists say you're getting 90% accuracy on training and you are getting 73% accuracy on validation. So your work item will vary based upon whether data scientist is telling you scenario 1 or scenario 2. So as a leader of a project, at a high level, what we read into it is if your model is not working well even on a training data.
So you're on the top one then?
Yes, on the top one. If your model is not even giving good accuracy on a training data, that means its architecture is not good enough.
Yeah.
In a second case, it is working well on a training data. Most likely you are in right direction. It is overfitting. That means now you need to apply variance reduction technique. So in machine learning, we use a term called bias reduction and variance reduction. So if you are, generally you want to get good result on training data and you want to also get good result on your test data. You want to get both, but when you build a model up front, you want to get confidence whether your architecture is right or not. So in this case, it tells us that you need to rethink into a model architecture. You need to try something else in a model architecture. In this case, it tells us, so as a leader or as a program manager of that team, you want to now put together detailed work item in your plan. So it is hard to do it upfront, but depending upon the result, you will put additional item. Okay. The other scenario can be, we talked about earlier that we took 1 million images from web, and we have these two options. If we are using the first option, then what I said in the previous slide is correct, and that's what most of the team uses it.
Yeah.
But now, if you use a different approach, so generally there is a best practice that divide your data into train, validation, and holdout set. But many times when we get experience, we also break those best practice. So in this case, we break the best practice that we want to optimize our images to find the garbage. So we didn't distribute it uniformly. We put more garbage images here in validation and holdout, and we put less garbage images in training. So now I will evaluate my result in a different way. So to evaluate the result, I will again have to carve out a train validation set and validation set and test set.
Yeah.
So if there is a large difference in this training set and train validation set, it tells me that it is again a variance problem. And I need to put a work items for variance, like there is a dropout, regularization, and machine learning techniques to handle variation problem. But if this area, there is not significant difference, and there's a significant difference between validation and this one, that tells us that because we are distributing the data in a different way, it is causing this issue. That means I need to find more images to put into this structure. So that's what makes machine learning very iterative, because the kind of work item we will identify depends upon what result we get from the data.
Yeah.
Here is another simple example. So we talked about machine learning architecture and how to refine it by looking at the result. So let's say now you feel comfortable that your machine learning architecture is right, you have distributed the data correctly. You want to improve the result further. Now, let's take an example that 12% of the images we are misclassifying. And your business is saying, okay, I'm ready to fund, we need to improve the result of this 12%. So you take some samples and you see whenever there is a rainwater on the street, we were classifying this as a garbage.
These are real life example you are giving.
Yes. And now if you are in San Francisco versus you are in Seattle, in San Francisco, number of rainwater images will be very less. So you realize like your total error is 12%, and only a small fraction of that images are rainwater. Versus if you are in Seattle, I live in Seattle, where most of the images will have rainwater. Yeah. So the impact is very different. So if you are working for San Francisco data or a data where there is a less percentage of rainwater images, fixing the rainwater images will only improve the result, very less result. But if you have a lot of rainwater images, let's say 50% of the images sample we took were the rainwater, then we know fixing the rainwater will reduce your 50% of error, which will be 12% to 6%. So as a leader of that team, then you can have that discussion with business stakeholders that, okay, we are going to invest time in this, and this is probably going to give maximum of this much of improvement.
Yes.
And it also helps you again in determining, because you have a limited time and resources, where to invest one. So in a case one, you will spend more money on finding out what other type of images are misclassified, so that you can find a low-hanging fruit. In second case, you have already identified low-hanging fruit, which is a rainwater images. Then you go and fix the rainwater images, and then your result get improved. So we are at the end. So the key takeaways are model building is a agile method. So use lightweight project management method. So we generally at Google use 6 to 8 weeks of model building, and we work with various customers. And we create one template. We use Google Sheet. We create one template in which there are multiple sheets. We describe project objective, what are the team, what are the stakeholder, what is the use case, what is the matrix, and what are the work items and deliverables, and reference to any links. So that is our one tool for collaboration.
Yeah, that's
our
really
customers
good.
also see it, we also see it, and we keep updating it. The work item for machine learning project, it is difficult to identify all the work item up front. So we identify the main items, and then as we see the result from the model, then we continue adding more sub items there. And the most important thing is when we do a machine learning project with customers and customer bring a complex project, the main value add as a leader we can do is we can identify which approach will work, which approach will not work. So instead of doing 20 iteration and finding it out, we only do 2 iteration and get the result.
Yeah, this is definitely experience talking here.
Yes, yes.
All right, Prashant, thank you so much for taking us through that. Really appreciate it. Michel, thank you for co-hosting with me.
That's a really good topic.
Yeah.
And I think it was more than just what we said at the beginning, because we went really deep into the subject, and it helps understanding how you would start from beginning. I have an ML situation, how I can start and be successful with it. Really
excellent. So, thank you. We very much appreciate you coming on, folks out there on YouTube. Thank you for taking the time. We appreciate it.
Thank you very much.
Thanks a lot.
Thanks for joining us for ML Week, and come back next week. We've got a couple more sessions for you, and one on Thursday will be another customer case study. So thank you again. Have a great day and have a great weekend.
Bye-bye.
Bye-bye.